My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications second semester subject Data Structures as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is: describe about stack. A stack is a type of data structure that works like a pile of plates. You add, push, a plate on top, and remove, pop, the top plate first. This rule is called LIFO, last in, first out. Main operations: push, add an item to the top. Pop, remove the top item. Peek top, see the top item without removing. Is empty, check if the stack is empty. Example in real life. Think of a stack of books. You always put a new book on top and remove from the top. Python example. Stack is equal to stack.append 10 hash push. Stack.append 20. Print stack.pop hash output 20 popped. Why use stack? Stacks are used in undo-redo features in apps, browser history, function calls in programming. Easy trick to remember. LIFO, last in, first out, like plates or books stacked on each other. 2. What is a queue? What is a queue? A queue is a data structure that works just like a line of people at a bus stop. The person who comes first is served first. This is called FIFO, first in, first out. Main operations: enqueue, add an item at the end, rear. Dequeue, remove an item from the front. Front, view the front item. Is empty, check if the queue is empty. Real life example. Think of a queue at a movie theater. The person who enters the line first buys the ticket first. Python example. From collections import dequeue. Queue is equal to dequeue. Queue.append 10 hash enqueue. Queue.append 20. Print queue.popleft hash output 10 dequeued. Why use queue? Queues are used in printing tasks, first file prints first. Customer service systems. CPU scheduling. Easy trick to remember. FIFO, first in, first out, like a line of people waiting for their turn. Next important short question is: 3. What are the applications of stack? A stack is useful when you need to reverse things or track recent actions. It follows LIFO, last in, first out, just like a pile of plates. Real life and programming applications. 1. Undo-redo in editors. When you type something and press undo, it removes the last action. Stack stores these actions. 2. Back-forward in browsers. Clicking back takes you to the last visited page. Pages are stored in a stack. 3. Expression evaluation. Used in solving math expressions like a plus b asterisk c and converting between postfix, prefix, infix. 4. Function calls, recursion. Stack keeps track of which function is running and what to return next. 5. String reversal. Push all letters, then pop them to get reversed string. Example. Stack is equal to for char in ABC. Stack.append char. While stack. Print stack.pop and is equal to hash output CBA. Easy tip. Stacks help in tracking recent actions, reversing, and nested tasks like function calls. Next unit 2 important. Long questions. First important long question is: representation of stacks. A stack is a special type of data structure that stores elements in LIFO order, last in, first out. This means the last element added is the first one removed. Imagine a stack of steel plates in a canteen. You always remove the top plate first. Two main ways to represent a stack. 1. Array representation of stack. In this method, we use a fixed size array and a variable called top to keep track of the last added element. Example. Stack is equal to none *5 hash stack with size 5. Top is equal to -1 hash stack is empty initially. Hash push operation. Top plus is equal to 1. Stack top is equal to 10. Hash pop operation. Value is equal to stack top. Top is equal to 1. Diagram. Index 0, 1 to 3, 4. Stack 10, 20, 30. Top points to the last added element. Pros, easy to implement. Cons, fixed size, can't grow beyond limit. 2. Linked list representation of stack. Here, each element is stored in a node, and each node points to the next. The top points to the last pushed node. Example. Class node. Self.data is equal to data. Self.next is equal to none. Top is equal to none. Hash push. New_node is equal to node 10. New_node dot next is equal to top. Top is equal to new_node. Hash pop. Value is equal to top dot data. Top is equal to top dot next. Diagram. Top 30, 20, 10, none. Pros, no size limit, memory is used efficiently. Cons, slightly more complex to code. When to use what? Use array when the size is known. Use linked list when size keeps changing or memory must be used efficiently. Easy tip to remember. Array fixed size. Linked list flexible size. Both follow LIFO and use push and pop operations. Let me know if you want the Hindi version too. Next important long question is 2 operations on stacks. A stack is a data structure that follows LIFO rule, last in, first out. This means the last item added is the first to be removed. Think of a stack of plates you add to the top and remove from the top. Stacks allow a few basic but important operations. Let's understand them with examples and easy words. 1. Push operation, insert item. This adds a new element to the top of the stack. Example, Python. Stack is equal to stack.append 10 hash push 10. Stack.append 20 hash push 20. Print stack hash output 10, 20. 2. Pop operation, remove item. This removes the top element from the stack. Example. Stack.pop hash removes 20. Print stack hash output 10. If you pop from an empty stack, it will cause an error. 3. Peek or top operation, view top item. This returns the element at the top without removing it. Example. Top_item is equal to stack -1. Print top_item hash output 10. 4 is empty operation. Checks if the stack is empty or not. Example. If not stack. Print stack is empty. Else. Print stack is not empty. 5. Size operation. Gives the number of elements in the stack. Print lay stack hash output 1. Real life example. Think of your school bag. The last book you put in is on top and is the first one you take out, just like a stack. Summary. Operation meaning shortcut to remember. Push add item to top, put in. Pop remove top item, pull out. Peek see top item, look at top. Is empty, check if stack is empty or not. Size number of items, how many. Easy tip, always remember last in, first out. Next important long question is 3 operations on queues. A queue is a data structure that works like a line of people at a ticket counter. The person who comes first gets served first. This rule is called FIFO, first in, first out. Let's learn the basic queue operations with easy words and examples. 1. Enqueue, insert item. This operation adds an element at the rear end of the queue. Example, Python. From collections import dequeue. Queue is equal to dequeue. Queue.append 10 hash enqueue. Queue.append 20. Print queue hash output dequeue 10 20. 2. Dequeue remove item. This operation removes the element from the front of the queue. Item is equal to queue.popleft hash dequeue. Print item hash output 10. Print queue hash output dequeue 20. If the queue is empty and you try to dequeue, it will give an error. 3. Peek or front, see first item. Returns the element at the front without removing it. Print queue 0 hash output 20. 4 is empty, check if queue is empty. Checks if there are no elements in the queue. If not queue. Print queue is empty. 5. Size, number of elements. Returns how many elements are there in the queue. Print lay queue hash output 1. Real life example. Imagine standing in line at a canteen. The first student who enters the line is the first to get food, just like in a queue. Summary table. Operation what it does, easy tip to remember. Enqueue add item at rear, join the line. Dequeue remove from front, leave after service. Peek view front item, who's next. Is empty, check if line empty, any students in line. Size count of items, how many in queue. Tip, remember FIFO, first in, first out, like students in a school assembly line. Next important long question is 4 types of queues. A queue is a data structure that follows FIFO, first in, first out, just like a queue outside a movie theater. The first person in line is served first. There are different types of queues, each used for different purposes in real life and computer programs. 1. Simple queue, linear queue. Elements are inserted at the rear and removed from the front. Follows the basic FIFO rule. Example. Queue is equal to 10, 20, 30. Hash enqueue queue.append 40. Hash dequeue queue.pop 0. Real life example, line at a railway ticket counter. 2. Circular queue. In this queue, the last position is connected back to the first, forming a circle. It helps to reuse empty spaces in the queue after deletions. Real life example. A rotating turntable where items come back to the start after the end. 3. Priority queue. Elements are served based on priority, not just position. Higher priority items are removed first, even if they entered later. Real life example. In a hospital, an emergency patient is treated before others, regardless of when they arrived. 4. Double-ended queue, dequeue. You can insert and remove elements from both front and rear. It is flexible and useful in many scenarios. Example in Python. From collections import dequeue. Dequeue is equal to dequeue. Dequeue.append 10 hash rear insert. DQ.appendleft 20 hash front insert. DQ.pop hash rear remove. DQ.popleft hash front remove. Real life example, a line at a toll plaza where cars can enter or leave from both sides. Summary table. Type special feature real life example. Simple queue FIFO, insert rear, delete front train ticket queue. Circular queue rear connects to front, reuses space round robin task handling. Priority queue high priority served first emergency room in hospital. DQ insert delete from both ends double-sided toll booth. Tip to remember. Every queue type solves a specific real-world problem, from hospital emergencies to task scheduling.